Dundigal. My name is Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about data transfer and manipulation. So, data transfer instructions cause data to be transferred from one location to another without affecting the binary information content. And data manipulation instructions execute arithmetic, logic, and shift operations on data. When a program is executed in a computer, program control instructions allow into to make a decision and modify its direction. While the collection, replication, and transmission of huge data sets from one recognition of business unit to another are done through the data transfer method, data manipulation instructions are those that are altered to the change the data content. So when I'm going for the data, I'm taking this data is a register R1 and it is the 8-bit. So this I want to convert to the another data, another register. So same data I have to convert to another same 8-bit data. So R1 is copying to the R2. Is it possible? Yes, it is possible to converting from R1 data to R2. Okay, it is the data transfer. So before going to the data transfer, what is the size of the register? Suppose R1 register size is 8-bit. So I am converting to the R2. Shall I go for same size or more than that one? But don't go for less size. Why? Because the data size is 8-bit. When I am transferring to that one, it is also should be 8-bit minimum. So that data transfer instructions cause data to be transferred from one location to another. That means R1 is located in one memory 1 or some location. So this R1 data is converted to the R2. So maybe this register is in another memory, is in the another memory location. It is a location 1 and it is a location 2. So when I am going for the location 1 to location 2. So R1 data of 8-bit is transferring to the R2 register of 8-bit. So these same data I am converting from one register to another register or same memory of one location to another location. So this location to another without affecting the binary information content. And data manipulation instructions execute arithmetic, logic, and shift operations. So what we are discussing here, same data R1 is copying to the R2. So that is nothing will be changed in that. Same data is copying. But what here means, shall I go for R2 register is using for arithmetic, logic, and shift operations. The one type of data is copying to the another data, that is executing the arithmetic, logic, and shift micro operations. So that is called manipulation. So data, same data copying to R1 to R2, that is a data transfer. But data manipulation means same data I am going for the using for arithmetic, logic operations. That is a data manipulation using for another operations. So when a program is executed in a computer, the program control instructions allow it to make decisions and modify its direction. While the collection, replication, and transmission of huge data sets from one organization or business unit to another are done through the data transfer method, the data manipulation instructions are those that alter or change the data content. So when a program is executed, means multiple operations or multiple operands or multiple instructions. Here we are taking multiple instructions. Multiple instructions I am taking as a one program. So this program executed in a computer, the program control instructions allow it to make a decision and modify its direction. While the collection, replication, and transmission of huge data sets from one organization or business unit to another are done through the data transfer method, the data manipulation instructions are those that alter or change the data content. So arithmetic instructions, arithmetic and logic operations are using for the data manipulation. So these arithmetic instructions are using for data manipulation. That arithmetic operations include addition, subtraction, multiplication, and division. some computers provide instructions only for addition and subtraction operations and generate multiplication and division operations from those two operations. Each instruction is represented by mnemonic code. So here the arithmetic instructions and their respective numeric symbols will be showing in the following. So arithmetic instruction means we are going for the add, sub, multiplication and division. So maximum more than we are calling as these are the arithmetic operations. So these arithmetic operations are addition, subtraction, multiplication and division, but some computers provide instructions only for addition and subtraction operations. Some microprocessors are supporting only addition and subtraction operations and generate multiplication and division operations from those two operations. So multiplication and division are for another operation, we are going for that one. So each instruction is represented by mnemonic code or mnemonic symbol. So here the arithmetic instruction. In the arithmetic instruction, first we are going for the increment. The increment instruction adds 1 to the value stored in the register or memory word. So what is the input value? For that input value, we have to add one value to that one. That is called increment. This increment operation we are calling as arithmetic instruction. So suppose I am giving equal to 110, 110, 11. We have to add plus 1 for that one. So we have to add plus 1 at the LSB side. Otherwise, if I am giving equal to 4, so increment means a plus, that is 4 plus 1. So this one I am going for as a arithmetic or increment value. Decrement means the decrement instruction subtracts 1 from the total value. So suppose I am giving equal to 4. What is the subtraction means? A equal to 4 minus 1. Suppose I am giving some binary value 1101. So I am going for the subtraction of this one. So what is the subtraction? We are going for the subtraction from LSB. So that is the decrement and arithmetic instructions. The arithmetic instructions are available for different types of data such as floating point, binary, single precision or double precision data. During the execution of arithmetic instructions, the processor status flags or conditional codes are set to designate the outcome of the operation. So the arithmetic instructions are available in different types of data such as floating point, binary, single precision, double precision. So I am going for the integer, float value or single precision or double precision. These are the different types of inputs we are giving for the arithmetic instructions or arithmetic operations. But during the execution of arithmetic instructions, the processor status flag or conditional code said to be designate the outcome of the operation. So what is the last value? I am going for the flag operation. So it is a flag, that is 0 or 1. So during the execution of arithmetic instructions, the processor status flag or conditional codes are set to designate the outcome of the operation. So that is a flag 0 or 1. So here some mnemonic symbols. Load. What is a mnemonic of load means? LD. Store. ST. Move. MOV. Exchange. XCH. And input. IN. Output. OUT. Push. Pop. Okay. So these are the instructions followed by mnemonic symbol. So any of the instructions, suppose I going for the move AX comma BX. So I am the value of BX is placing to the AX, that is a move AX comma BX. So where is there move? MOV. So the instruction name is MOV. I have to add two registers AX comma BX. So what is the operation is going on? It is the addition operation. So in the mnemonic code, it is going for the add means addition. So I am going for the input value. What is the output? Exchange AX comma BX. Suppose I'm going for the XCH R1 comma R2. What is this meaning means the R2, what are the values of R2? Those values are exchanging. So those are converting to the R1. That means exchange of R2 to R1. Otherwise, I'm going for the exchange R1 means the R1 register is exchanging with another register. So here there are so many are there. These are the sample numeric symbols are there. Loading the function, loading the register means LD R1. That means the value of R1 register values are loading to the another one. Store means ST, storing the values of register or some data. Move the value from one register to another. Exchange the values, exchange the register values, or exchange the data from one register to another. And input, what is the input I am giving? Suppose keyboard and mouse I have to give in keyboard in. So what is the input you are giving to the processor? And the out means output. What are the output connections we are connecting? And the push and pop conditions. So data manipulation instructions. Data manipulation instructions perform operations on data and provide the computational capabilities for the computer. The data manipulation instructions in a typical computer usually divided into three basic types as follows: arithmetic instruction, logical and bit manipulation instruction, shift instruction. So the data manipulation, and manipulation means we are forming or we are converting to the arithmetic logical operations. Or suppose R1 data is converting to the R2 or R2 to R1. What is this means? It is a data transfer. Data transfer. But same registers, these are I'm using for same registers I'm using for arithmetic operations, logical operations, and shift operations. So for these operations I'm using R1 or R2. That is called data manipulation. Data transfer means R1 data is copying to R2, R2 data is copying to R1. So that is a data transfer. So data manipulation instructions perform operations on data and provide the computational capabilities for the computer. The data manipulation instructions in a typical computer usually divided into three basic types as follows: arithmetic instruction, logical instruction, and shift instructions. So arithmetic instructions means addition, subtraction, multiplication, and division. These are the arithmetic. And the logical operations means and, or, not, NAND, NOR. So these are the logical operations. Okay. Another one is a shift operations means shift left, shift right, circle left, circle right, like this. So these are the arithmetic, logical, and shift operations. These are calling as a data manipulation. So arithmetic instructions. The four basic arithmetic operations are addition, subtraction, multiplication, and division. Most computers provide instructions for all four operations. First one, increment. I have to increment the value INCB. That means the data, the register value IB, INC means the register value is incrementing by 1. It will be incrementing by the register B by 1. That is B tends to B plus 1. So what is the B value? It will be incrementing. How much means? Plus 1. So what is the value of B? That will be incrementing 1. So decrementing. DEC B. That means B tends to B minus 1. So what is the value of B? That will be decremented by 1. That is a B minus 1. Add. It will be add contents of register B, that the contents of the accumulator, and store the result of the value is stored in accumulator. AC tends to AC plus B. That means the value of register, what is the resultant value, that will be stored in accumulator. So the resultant value is stored in accumulator. So accumulator is a register to storing the resultant value. So here add means we are adding the content of B to the accumulator. So suppose addition means how many values we need, minimum 2 values we need to add. So first value is stored in B. Where is another value? So we have to define with accumulator. So the value of input value is in one value is in accumulator, another value is in B. Suppose A equal to 1, B equal to 2. Here already we know that B equal to 2 is there. But where is A? I am taking as it is a accumulator. So accumulator is automatically it will be generated as accumulator equal to 1. So accumulator is one input, P is the another input. So the resultant value will be stored in accumulator. That is accumulator equal to accumulator plus B. Actually already accumulator value is 1. The value is 2. 1 plus 2, 3. These 3 values storing in accumulator. So next one, multiplication or multiply, MULB. It will be multiply the contents of registers B with the content of accumulator, and it stored the resultant of accumulator equal to accumulator into B. So A equal to 4 and B equal to 3. We have to multiply 4 into 3. So that means the value 4 is equal to accumulator and B value is 3. 4 into 3 is 12. The 12 value is stored in accumulator. And division. Accumulator equal to accumulator by B. So the first input value is A is equal to 4 and B. What is the result value? Stored in accumulator. And add with carry ADDC, the contents of the accumulator, and stores the result value in accumulator. That is the accumulator equal to accumulator plus B plus carry flag. So accumulator equal to what is the input value? One is accumulator, another value is B value, and the carry is there any carry will become? Yes, the carry will be added. If no carry means there is accumulator equal to accumulator plus B. But here ADDC means definitely we will get the carry. Then only we have to define with ADDC. If I am not getting carry means no need of take this ADDC. Directly I will take ADD. Subtract with borrow. So if I am going for the borrow, if I need a borrow, then I am going for the SUB sub with borrow. SUB with borrow. It will be subtracting the contents of register B and the carry flag from the contents of the accumulator and stores the result in accumulator. AC tends to AC minus B minus carry flag. That means accumulator value equal to accumulator minus I am borrowing that one. Is there any carry flag? It will be like this. And negate 2's complement means already when I am going for the subtraction, that is called 1's complement. So when we are going for the subtraction, then only I need 2's complement. A minus B, B minus A, like this. So for the subtraction values only I need 2's complement. It will negate a value of finding 2's complement of its single operand. This means simply operand by minus 1. B equal to B bar plus 1. B equal to B bar plus 1. So B bar equal to 1's complement plus 1. That is called 2's complement. 1's complement plus 1 equal to 2's complement. Logical and bit manipulation instructions. Logical instructions perform binary operations on strings of bits stored in register. They are useful for manipulating individual bits or a group of bits. So logical or bit manipulation. Clear means we are clearing the accumulator value. Complement means complementing the value. Add and means add and or. So clear means suppose my accumulator value is 110, 110, 11 is there. I have to remove this value. That means clear AC. That means accumulator value will be clear. So there is no value in accumulator. Complement. Suppose accumulator value is 110, 110, 11. So what is a complement of accumulator? Means 1 converting to the 0, 1 to 0, 0 is converting to 1, 1 is changed to 0, 1 is changed to 0, 0 is 1, 1 is 0, 1 is 0. So it is the complement of accumulator. A equal to A complement, B equal to B complement. So we are taking the opposite values, accumulator, complement being COM, complement of A. What is the A value? Suppose here I'm taking accumulator value, some 1101. What is the complement of A? Complement of A means complement of accumulator 0010. So that is a complement. And means we are A into B. Suppose I want A into B. How it is possible means and logic gate to A comma B, and A comma B means we are multiplying A and B. A equal to 1, 0. What is A into B? 1 into 0 equal to 0. Like this. So I am taking 0 into 1. 0 into 1 means 0. Like this. So and means I am taking multiplication. It will be adding the content of register B and will the contents of the accumulator and store. It is the accumulator AC equal to AC and B. A into B. AC and B means A into B. So OR means A plus B. OR means addition of this one. So A, B, A plus B. 0, 0. What is the value? 0 plus 0? 0. 0, 1. That means 0 plus 1? 1, 0. 1 plus 0? 1. Like this. So it is a OR. It will be OR in the content of register B and with the contents of accumulator and store it in the accumulator. So the resultant of addition value is stored in accumulator, final accumulator. Exclusive OR, XOR. It will be XOR the content of register B with the content of accumulator and store it in the accumulator. That is a XOR. Clear carry means what are the carry values are there? It will be clearing. And set carry means it will be carry a flag to 1. If anything carry will be generated, then I am going for the set carry. Means we have to create a carry. If maybe the carry will be generated. Complement carry means we have to complementing the carry value. Suppose carry flag equal to 1. Flag equal to 1. Carry complement carry means we are complementing. That is a flag equal to 0. Suppose my flag equal to 0. I have to complement this one. Complement means 0 bar equal to 1. So flag 1 is complement means flag 0. Flag 0 complement equal to flag 1. So enable interrupt is there is no interrupt in the microprocessor in the computer. So we have to generate an interrupt. That is a enable interrupt EI and disable interrupt. So there is no multiple tasks are going on in microprocessor. So we have to disable the interrupt. That is called a DI means disable the interrupt. And shift instructions. Shift are operation in which the bits of what and are moved to the left to right. Shift instructions may specify either logic shift, arithmetic shift or rotate type of shift. So shift operations are maybe shift means left to right. It is from right to left or left to right. So shift are operations which the bits or what are moved from left to right or right to left like this. Shift instructions may specify either logical shift, arithmetic shift and rotate means circular shift. So logical shifts are 2 types, arithmetic and rotate are 2 types. How? Logical shift right, logical shift left. And arithmetic shift right, arithmetic shift left, 2 types. Rotate right, rotate left, 2 types. Total how many? 6 types are there. Rotate right through carry, rotate right through carry, that is ORO RC. Rotate left through carry, that is ORO LC. So shift instructions are 3 types: logical, arithmetic and rotate. In the logical 2 types, shift left, shift right. In the arithmetic 2 types, arithmetic shift left, arithmetic shift right. And rotate means rotate 2 types, or rotate left, rotate right. So clear means CLR, complement means COM, AND gate means AND, OR gate OR, exclusive OR means XOR, and clear carry means CLRC, and set carry SETC, complement carry means SOMC, enable interrupt EI, disable interrupt DI. So these are the references of data transfer. So today we discussed what is the data transfer instructions? Cause it to the data, and the data to be transferred from one location to another without affecting the binary information. So I'm shifting R1 8-bit to R2 8-bit. Is it possible? Yes. This 8-bit is transferring to R1 to R2. That is a data transfer. When a program is executed in a computer, program control instructions allow it to make a decision and modify its direction. So one type of data transfer to the another type of data transfer. Is it possible? Yes, it is possible. And what are the operations we have to done means addition, subtraction, multiplication, division. That is the arithmetic operations, logical operations. These are the data manipulations. And arithmetic instruction. Arithmetic operations include addition, subtraction, multiplication, and division. Some computers are accepting addition and subtraction operations. Some are generating multiplication and division operations of this one. So arithmetic instructions, increment, decrement, arithmetic operations are like this. And incrementing means we are adding +1 to the value. What is the result value? We are adding +1 to the result value or to the input value. Input +1. Decrement means we are going for the input -1. So I am taking one R1 register, that R1 -1 like this. And arithmetic instructions. Arithmetic instructions are available for different types of data such as floating point. So arithmetic instructions, what are the inputs are generating means integer, float, precision or double precision. During the execution of arithmetic instructions, the processor status flag or conditional codes are set to designate the outcome of the operation. Load, LD, store, ST, move, exchange, input, output, push, pop. These are the mnemonic symbols of the data transfer. And data manipulations means arithmetic instructions, logical instructions, shift operations or shift instructions. These are the data manipulations are there. In the arithmetic instruction, what are the mnemonics means what are the instruction code. Instruction code means INC, that means increment. DEC means decrement. So these are called, we are calling as a instruction. ADD, addition. MUL, multiplication. DIV, division. Add C means addition with carry. So these are the instructions, that is called mnemonics. Or subtract with borrow, SUBB. And two's complement, negate two's complement, NEG. Logical and bit manipulation instructions. Suppose I am going for the clear the accumulator, CLR. That means accumulator value will be clear. So what I am using the registers R1, R2 accumulator. So CLR means that is only the accumulator will be clear. COM, that means complementing the accumulator value. And add means where adding means multiplying, and means we are multiplying the two registers. So suppose I am taking B value and B means that means already B is there. What is another input? And means minimum two inputs I need. One input already we know that is a accumulator. Another one is a B input, A into B, that is a accumulator multiplying with the value of B value. And OR means we are ORing means adding A plus B, accumulator plus the input value is B. Exclusive OR, clear carry means where carry will be clear, and carry means I have to create a carry, that is a set carry. Complementing carry means the carry value is complementing. And enable interrupt. Interrupt is not there, but we have to enable. And already in the input enable the interrupter, so we have to go for the disable, that is a disable interrupt. And shift instructions means three types: logical shift, arithmetic shift, rotate shift. So shift, logical instructions, shift operations, arithmetic shift operations, rotate shift operations. So in the logical, two types: logical shift right, logical shift left, SHR, SHL. Arithmetic shift right, SHRA, shift right A. Arithmetic shift left of A. Rotate right, ROR, rotate right, rotate left, ROL, rotate right through carry, rotate right through carry, C, rotate left through carry. So these are the mnemonics or instructions of data transfer or manipulation. Clear means CLR, complement COM and AND, or exclusive or X, or clear carry CLRC, set carry CTC, complementing carry COMC, enable interrupt and disable interrupt. Okay, these are the data transfer and manipulations. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.